Hi there. For this video, we are tasked to find the value of this radical expression. Now, the process here at first might seem complicated, but it will eventually get better as we go on through the solution. So the first thing that I would do is that I would multiply 4/4 in each of these terms. So by multiplying 4/4 out here, we can do this since 4/4 is simply equal to 1. So it's the identity element. Furthermore, I will actually write 4/4 as 4/2 squared, since that is still the same. So this expression here will become the square root of 3 times 4/2 squared plus the square root of 3/2 squared times 4/2 squared plus let's extend this further, square root of 3/2 raised to 6 times 4/2 squared plus the square root of 3/2 raised to 14 times 4/2 squared. So upon simplifying this, we will have here this one. First term will be 12/2 squared plus the square root of 12/2 raised to 4 plus the square root of 12/2 raised to 8 plus the square root of 12/2 raised to 16, and so on. So let's just clear some space out here. So for now, we have converted the expression into this one. Now note here that this one out here, this one is actually equal to 1/2 times square root of 12 plus square root of 12 plus square root of 12, and so on. So this is our claim, and this is what we will show to be true in the following steps. So this is like the complicated part of the solution. So from our claim, note that when we distribute this 1/2 inside the radical expression out here, or the radical sign, we will have the square root of, first over here, so this will be 1 squared over 2 squared times 12 plus 1 squared over 2 squared times square root of 12 plus square root of 12, and so on. So the reason that it became 1 squared over 2 squared is that because we put this 1/2 inside the square root function. That means it must gain a square out here, so that when we bring it out back again, it will still have 1/2. So simplifying this expression, we will have, let's erase this one, we will have 12/2 squared. Now after that, what we will do is we will bring this one out here inside again out here. So when we to that one, this one will become, this one will become 12 over 2 squared plus the square root of, when we square this one, this will become 1 raised to 4 over 2 raised to 4 times 12 plus 1 raised to 4 over 2 raised to 4 square root of 12, and so on. Now observe here that when we simplify this expression out here, this will become 12 over 2 raised to 4. Now as you can see, so far, this one, this 2 out here matches this. And actually, if we continue this process from on the following radicals inside, we will actually obtain this one and this one. So you can verify that one, but by the first few terms, we can conclude that this expression out here is actually equal to this one. So let's erase this first. Oops. And so we have written this complicated radical expression into just this one. Now from this one, what we can do is we can let this one to be equal to x. Then we know that x squared is equal to 12 plus x. And so upon simplifying this, we will have, or rather some rearranging of the terms, we will have x squared minus x minus 12 equals 0. And this one factors into x minus 4 times x plus 3, which implies that either x is equal to 4 or x is equal to negative 3. But observe that x cannot be negative 3, since this expression out here is positive, or it should be positive, since recall that when we have square root of x squared out here, its outcome is absolute value of x, so it must always be positive. And so the only case that we take is x must be equal to 4. So given that, we know that this one out here is equal to 4. So this one is actually equal to just 1/2 times 4 is equal to 2. And that is the final answer for this one. So we were able to simplify that complex radical expression into just a single number. So that is how we solve this one. The key is having a good grasp of how radicals work and what happens when, example, if we have 2 squared root of 2, what happens when this 2 go back inside here. So that would be 2 squared times 2. So that's how it works. So when we remove it back, we will obtain this one back. So having a idea on that, and after that, the key is just observing how we can convert this into a quadratic equation, and the rest is just simple solving on algebra. So I hope you enjoyed this video. Feel free to comment down below your questions on this problem, as well as your suggestion for future videos, and share also your solutions to this one if you have another solution. And yep, that is all for this video.